Good day, students. Welcome back to our math virtual classroom. Today's discussion is about equations transformable to quadratic equations. The learning competency for this topic solves equations transformable to quadratic equation, including rational algebraic equation. There are equations that may appear not quadratic in form, but when analyzed and simplified, they can be transformed into quadratic equation. So let us solve these kinds of equations. Let us have example number 1. Given quantity x plus 3 squared minus 2 times quantity x plus 3 minus 8 equals 0. Take note that you have here same quantity. So to transform this into quadratic equation, we could let b be equal to quantity x plus 3. Thus, by substitution now, your equation will become b squared minus 2b minus 8 equals 0. So this is your equation now. How are we going to solve it? We solve it by factoring. So remember that in factoring, we consider the value of a and c. But since on this equation, a is equal to 1, therefore its factors are 1 and 1. So let us just consider the value of c, which is negative 8. What are the factors of negative 8? That will give you negative 2 when added. Okay, negative 4 and 2. When you add the two digits, that would give you negative 2, which is equal to the middle term. So we will use of negative 4 and 2 in factoring. So the factors now are quantity b minus 4 and quantity b plus 2 equals 0. So let us solve for b. So by zero factor property, let us start with b minus 4 equals 0. Let us add 4 on both sides of the equation. This will become 0. b now is equal to 0 plus 4 is 4. Okay, the other one is b plus 2 equals 0. So to simplify, we simply add negative 2 on both sides of the equation. So by inverses, this will be 0. b now is equal to negative 2. Since b is equal to quantity x plus 3, then let us solve for x. Let us substitute the value of b, which is 4 and negative 2. Let us start with positive 4. 4 plus 3 is equal to 4. So to isolate x, we have to add negative 3 on both sides of the equation. So by inverse property, that would be 0. Therefore, your x now is equal to 4 minus 3. And 4 minus 3 is equal to 1. So the value of your x is 1. Now let us have the other one. X plus 3 is equal to negative 2. So to isolate x, we have to add negative 3 on both sides of the equation. Again, this will be 0 by additive inverse. X now is equal to negative 2 minus 3. And negative 2 minus 3 is equal to negative 5. Therefore, the solution of the original equation are 1 and negative 5. Another example, 4x to the fourth plus 7x squared is equal to 2. Examine the two variables, x squared and x to the fourth. We can get x to the fourth by multiplying x squared and x squared. Therefore, we could let x squared be equal to m. And by substitution, we could transform the equation into 4m squared plus 7m equals 2. And now, we can solve this using factoring. But before that, let us transform the equation in standard form. So how are we going to transform the equation in standard form? We have to let the right side of the equation be equal to 0. So to make it 0, let us add -2 on both sides of the equation. So adding inverses will give us 0. Therefore, our equation now will become 4m squared plus 7m minus 2 equals 0. Okay, let us continue solving. The equation is 4m squared plus 7m minus 2 equals 0. We solve by factoring. Remember, in factoring, we consider the value of your a and the value of your c. So in this example, a is 4 and c is equal to -2. So by trial and error, let us say that we will use 4 and 1 as factors of 4. And for -2, we will be using -1 and 2. Let us multiply the given diagonally. So that would be 1 times -1 will be -1, and 4 times 2 is +8. Now, when you add 8 and -1, that would give you +7. And therefore, we have correct factors. So we will just affix the coefficient m for this one. So that would be quantity 4m minus 1, and the other one will be quantity m plus 2 equals 0. So by zero factor property, let us now solve. 4m minus 1 equals 0. We first isolate the variable m. So let us add 1 on both sides of the equation. Inverses are 0 when added. So the resulting equation now will be 4m is equal to 1. The next step is to divide both sides by 4 so that the coefficient of m will be equal to 1. So that is 1. M now is equal to 1 over 4. On the other hand, m plus 2 is equal to 0. Again, our aim is to isolate m. So let us add -2 on both sides of the equation. That would give us, okay, that would be 0. M now is equal to -2. So the computed value of m are 1/4 and -2. We use these values to solve for x. Since x squared is equal to m, and the computed value of m are 1/4 and -2, then by substitution, x squared now is equal to 1/4, and the other one will be x squared is equal to -2. We can now solve the given by applying the square root method theorem. So we simply get the square root on both sides of the equation. So let us start with 4 squared equals 1/4. The square root of x squared is x, and the square root of 1/4 is positive and -1/2. On the other hand, we do the same method. We get the square root on both sides. Square root of x is x. But take note that we do not have a negative root. So no real roots for the value of -2. Therefore, we use positive and -1/2 as the roots of the given equation. Now it's your turn. Solve for real solutions of each of the following equations. If you forget the steps in solving, you could go back to our video.